Hello everyone, welcome back to my channel. Now we are going to start off with new course, that is MCQs on electric circuits. Starting off with a question.
Instantaneous power in an inductor is proportional to. So it will be proportional to instantaneous current and rate of change of current. So we know that VL is equal to di by dt. So where di by dt is the instantaneous current value. We know that the instantaneous voltage across the inductor is expressed as product of inductance and rate of change of current through it. So power is expressed as product of current and voltage. So it is VL is equal to L di by dt. So instantaneous power is equal to instantaneous current into rate of change of current. Next, the voltage induced in an inductor is represented as. So voltage induced is represented as product of its inductance and rate of change of current through it. VL is equal to L di by dt. So instantaneous voltage across the inductor is expressed as product of inductance and rate of change of current, as it doesn't allow any certain change of current through it. So voltage induced will be this expression. Next, absolute permittivity of dielectric medium is represented as. So it will be epsilon r into epsilon naught. So epsilon r is relative permittivity of the medium, which is actually ratio of actual permittivity of the medium to absolute permittivity of air or vacuum. And the absolute permittivity of air or vacuum is expressed as epsilon naught. So it will be epsilon r is equal to epsilon by epsilon naught. So we have epsilon as epsilon naught into epsilon r. That is relativity. That is relative permittivity into absolute permittivity of air or vacuum. Next, magnetic flux has a unit of. So it is a unit of Weber. The unit of magnetic flux is called Weber, and it has another unit named as Maxwell. 1 Maxwell is equal to 10 to the power minus 8 Weber. Next, if all the elements in a particular network are linear, then the superposition theorem would hold when the excitation is. So it will hold when either it is AC or DC. So superposition theorem can be applied for both AC as well as DC excitation to calculate the voltage or current calculations. It holds for both DC and AC if the circuit is linear, but superposition is not applicable for power calculations. Next, in balanced bridge, if the position of detector and source are interchanged, the bridge will remain balanced. This can be explained from which of the theorem? So it will be reciprocity theorem, in which when the response to excitation is constant even though we interchange the excitation and response. So reciprocity theorem is verified for a given network. So this is a condition. Next, if P is the power of a star connected system, then what will be the power of an equivalent data connected system? So the power will be P. We know that power of star or delta is root 3 V L into IL. So power in both of the connections is either same. It is same actually, whether it's star or delta. Next, which of the following is or are active elements? So both voltage and current source are active elements which are capable of delivering energy independently for long time or ideally infinite time. Both voltage and current are active elements and they can change energy level of a circuit. Next, which of the following are passive elements? So resistor and bulb both are passive elements. When the energy is not capable of delivering the energy independently are called passive elements. Both of these are passive and they can't increase the energy level of the circuit. Next, power dissipation in ideal inductor is, so it is 0. We know that internal resistance of ideal inductor is 0. As there is no resistance, there should not be any power dissipation of power. So pure inductor has no restricted component, so it active power dissipation is 0.
Okay, so if you like my videos, you can also subscribe to my channel. And if you have any doubt, you can always ask me in the comment section below. Thank you.